Gators.
Okay. So, there we go. It's recording now. So, exponent law. We're kind of looking at three different rules. We're looking at product, which is multiplication, quotient, which is division, and then power over power, which is like having a power involved. Okay. So an exponent to an exponent. So I think they're pretty simple, but I tend to find things simple that confuse kids, which is okay. So let's look at this first. X squared times x to the 4. Okay. What does x squared mean? X squared means x times x. Do you agree with that? Yes, no, maybe so? Perfect. And now what does x to the power 4 mean? It means x times x times x times x. Correct? So now, if I had to write this as exponent, how many x's do I have? 1, 2, 3, 4, 5, 6. So I could rewrite that as x to the power of 6. Do we understand how we went from all three steps here? We expanded it to be expanded form, and then we simplified it. Now I could use this with numbers too, numbers with exponents on it. So 2 to the power 3 would be the same as 2 times 2 times 2. And 2 to the power 4 is 2 times 2. And this would all come to 2 to the power of 5. 2 times 2 times 2 times 2 times 2. Right? Do you guys see how I did that one? Yes, no, maybe so?
No.
All right, so here, I'll do another one. I'll change up the colors. Let's go y to the power of 3 times y to the power of 4. Okay? We're going to multiply those two together. If I expand, like what does y to the power of 3 mean? Well, it really means y times y times y, right? Y to the power of 3 is y multiplied by itself 3 times. Then y to the power of 4 would be y times y times y times y, right? Do you see, Riley, how where the yellow ones are, for lack of a better term, where the blue ones are?
Yeah, and basically, aren't you timesing in between the green and the blue?
Yeah, they're all multiplied by each other.
Yeah,
now, what does that simplify to? Well, that would simplify to y. And how many times we times them by each other? 1,
7.
2, 3, 4, 5, 6, 7. Good. Okay. Now, does anyone see a pattern of how we get from the question to the answer? Does anyone see like a shortcut they could take? Good. Olivia had a suggestion there. You add the exponents. So if you look here, 2 plus 4 is 6. 3 plus 2 is 5. 3 plus 4 is 7. Okay. So let's take a look at this one here. We'll do this one just to make sure, and it's got a little trick in it. And let's go with. So if I were to expand this out, I'd have 3 purple ones. 4 times 4 times 4. What's how many green ones do I have? How many green 4s do I have? I just have 1. And for every number we write there, there's actually a 1 stuck up there. Okay? We never write it because it's, and that's going to equal, we add them all together, 1, 2, 3, 4, 5, 6. 4 to the 6. Okay? So I want you guys to try this one here. What's x to the 10 times x to the 3? Now in chat, how you write this is x. Let's do x with a number beside it. Just write the number beside it. Okay, in chat, and tell me what you think that is. What's the answer for that one? Actually, we will do this. So when you write in chat, there's like a little hat symbol, which is above the 6. Okay. So write x, the little hat, and then numbers. Let me see in chat, what do you think the answer is for this question? X to the power of what? If we look up here, our code was to good. X to the power 13. Perfect. Hey, there's San Vito. Perfect. So x to the power 13. Oops. And the middle part there would be, if I was breaking down to the middle part, it would be x 10 plus 3. Good. How about this one? 4 to the power 6 times 4 to the power 2 times 4 to the power of 4. What's that one? You're half right, Riley, because did my 4 change up here?
Yeah, I don't know why I clicked 8 instead of 4.
That's no problem. It makes sense. In a way, I understand why. There's lots of people who do that. Good, 4 to the power 12. Perfect. So our rule, if we had to write a rule up here, I have x to the a times x to the b. That equals x a plus b. Does that make sense of what I wrote there? So a and b are just variables that kind of represent your numbers. So you're just going to add the 2 exponents together. How are we feeling about the product rule right now? Thumbs up, thumbs down? Or out of 5. Let's do out of 5 again, like we usually do. Out of 5, how much do you understand it? 4, good, 5. Well, I'm going to mess with you, so we're going to get you off your 5. Good. Okay. Dominic's doubling up. Okay. So let's do a couple more. Now, the thing here is, in order to add them, I could not do x to the 10 times 2 to the 4. Because the bases, these are the bases here, are not the same. This would equal 2 to the 4 x to the 10. I can't combine them because the bases are not the same. Okay? So let's do this one here. 2 to the 3 times 2 times 2 to the 10. Okay? Give me that answer there. Looking at this. Who can give me the answer for that one? Two to the 14, 2 to the 14. Good. 2 to the 14 is correct, and there is a 1 up there. You guys, I want to make sure there's a 1 up there. Good. Now, the only thing that kind of confuses people sometimes with this is if I have this here. 2x4 times 4x8. Okay, so what we have to do here is this is going to multiply with this, and this here, those numbers out front are going to multiply against each other. Okay, so that's going to equal, so 2 times 4 are going to go together, and x4 times x8 are going to go together, which is going to equal x12. So the answer there is going to be 8x to the 12. Oh, you can only see my face. Am I not sharing my screen?
No, you just were.
Okay. Andreas was blessed with only my face,
Wait,
which I
so
want no one.
So you multiply x, but then you add the what's it called?
So the numbers will multiply against each other.
Yeah.
Right? And then the x's multiply with each other.
Yeah, that's what I meant.
Yeah. So coefficients by coefficients, and then variables by variables. Does that make sense? Okay, let's try this one. Let's do that one real quick. You guys can tell me in chat what you think the answer for that one is. So Dominic agrees with Riley. Logan does. Good. So that is correct. Because that would be x4 plus 3 and y 10 plus 2, which would be x7, y12. Perfect. Now let's try this one then. 4xy times 10x6y3. x7y4. Perfect. So that's going to be 4 times 10. And then this would be x1 plus 6 and y1 plus 3, which would equal 40 x7 y4. Perfect. Good. So that is your product rule or multiplication rule. So if you guys had your notes out the future self, I'll print it out. You could go in here and the rule is this part here. Is like xa plus b. And then you could write an example of it. What I would do for an example is do one, like this here would be a great example in my mind. okay? Because you can see how they multiply together, the coefficients by coefficients, and each variable goes together. Perfect. How do we feel about the product rule out of 5? Harley's good. Andreas, you're good. Good. Okay. So let's go on to the quotient rule, okay? Quotient's just a fancy word for, oh, do I even know how to spell quotient? Jeez Louise, my brain has left me. Quotient. I always write rule up here, so you always come back to this note. The quotient rule is just a fancy word for division. Let's go like this one. Let's go x to the 5 divided by x to the 3. Okay? Now let's expand it. So x to the 5 is x times x times x times x times x divided by x to the 3, and x to the 3 is x times x times x. Okay? So now we have this, we can cancel some out, right? So this one we cancel with this one. We'll do them all in different colors. So maybe these are going to cancel, and these are going to cancel. So what are we left with? We're just left with x times x, which is x squared. Okay. I'll do one more, and then you can tell me what the quick way to do this is. What's the shortcut? Okay. So 2 to the power 4, 2 to the power 3. That's going to equal 2 times 2 times 2 times 2. That's what 2 to the power 4 means. And 2 to the power 3 is 2 times 2 times 2. Therefore, let's start these will cancel out. Right? These cancel out. These cancel out. So we're just left with 2, or we want to write an exponent, 2 to the power of 1. Does anyone have a shortcut yet? Andreas, you can give me less information next time. Okay. The way I can. So you subtract the exponents. Good. So it's a minus b. So that's going to be our rule. So we subtract the top exponent, the bottom exponent by the, subtract the bottom exponent from the top exponent. Perfect. So I'm going to give you some questions then real quick. So we have x to the 10 over x to the 6. What's that going to equal? Good. X to the power of 4. How about 4 to the power of 8 and 4 to the power of 5? What's that going to be? Good. Now, I'm not going to tell you how to do this one. But let's try to use our prior knowledge from what we just did before.
Since it's two different numbers, doesn't it like not work?
No, it still works. Just like, think about what you did back here.
Oh, okay.
Okay. So we go, if I underline these, not quite, Gene. Think about back. We go coefficients by coefficients. So it's going to be 10 divided by 2 and x 6 minus 2. So that's going to equal, with me, 5 x to the 4. Okay. So we're not minusing. Remember, coefficients are they're just numbers. So they act like just numbers. Okay. Let's do another one.
4, because I got the. Aren't you supposed to?
Oh, that's
minus,
2. Sorry, I wrote down the wrong numbers there, didn't I?
It's like, oh my god, did I seriously just myself? Okay.
No, my bad. There you go. You're half right, Abigail. You have to remember there's a 1 up there. But your y1 was perfect. So that's going to equal x3 y4. Let's see what we have here. Good. So we're going to do 20 over 5, 20 divided by 5. And then our x's are going to be x12 minus 10. And the y is going to be 4 minus 3. So we're left with y. We're left with x squared. And we're going to have 4. Yeah, no problem, Riley. I saw it. How do we feel about, oh, I'm going to give you a hard one. I'm going to mess with you a little bit. Oops. Let's try this one. Don't overthink this one. Everything's right, Riley, except for the very first one. My question would be, why did you change it to a 1?
Are you supposed to divide them?
Yeah, but is it a coefficient or exponent?
Oh, I see. Yeah, so it would just be 2 instead of the 1.
Yeah, that isn't a coefficient. That's just an exponent, right?
Okay.
Just like we did, I think we did it up here with some numbers, right? Right here. Oh, what did I do there? I am losing my beans here for a second. I should say 4. So the answer here is going to be,
Oh, so if let's say it was like 2x, then you do it, but if it's by itself, then you don't.
correct. Yeah, this is an exponent. So that's going to be 2 to the power 2, x to the power 4, y to the power 1. Right? If I had this with the same things, these here are coefficients, right? All right, how do we feel about division out of 5? Good. All right, so now we're doing power of a power. So that means, let's say we have x squared to the power of 3. Okay? So what does x squared to the power of 3 mean? Well, that would be x squared times itself 3 times. Oops. X squared times itself 3 times. And what's the answer for this part here? Can someone write that in chat for me? Riley, it's not a dog. What's the answer for this part here? What's x squared times x squared times x squared? X to the power of what? X to the power of 6. Good. Let's try this one. What's 2 to the 4 to the power of 4? Okay. Well, if I write that out long ways, it's 2 to the 4 times itself 4 times, which would be 2 to the power of 16 when I multiply all these together. So can someone come up with a rule for me? Looking at these two examples, can we come up with a rule, or do you want me to do one more?
Mr. O, what do you call that? So it would be at the top there, it would be 2 to the power of 4. And then what do you call the other 4? Like how would you say that?
That'd be to the power of 4.
So
2 to the
basically,
power of 4 to the power of 4?
you're not actually
Correct.
timesing it. You're basically just adding it 4 times.
No, I know. It's just I'm just wondering what you call it, like what you say.
Yeah, that would be like x squared to the power of 3. Or x to the
Oh, I
power of
see.
4 to the power of 4.
I get it.
Let's do one more. Let's go y to the power of 5 to the power of 3. So that's going to be y to the 5 times y to the 5 times y to the 5. And that answer is going to be 5 plus 5 plus 5 is y to the power of 15. So can someone tell me how to make a shortcut? How can we how can we have no middle step? What's our shortcut?
You just add the 5 and the 3.
That would equal,
Basically, this
Oh no, you just
times
multiply it. Sorry, you just multiply it.
just do y5 times the power.
Yeah.
That's just
not
easy.
y 5 times the power, but 5 times 3.
Yeah, 5 times
I
3.
understand what you say.
5
Yeah.
times 3, and then just put it in the y.
So my rule here would be x a times b, if you understand what I'm doing here. Oops. I want to make that red. Make all my stuff. I'm going to scroll up here. We're going to use this as our example. Like if you want to write down a really nice example in your notes to self in the future, that box is really nice. So let's do a couple and we'll do some shortcuts. I'll take a little bit longer. Let's make it hard right away. What's that going to equal? Do we all agree with Riley? Oops. Good, good, good. A little less enthusiasm, Benjamin. I don't want anyone having nightmares. Now, let me do this one with you. No problem, Ben. So if we follow the rule, right? That's going to be 4 times 4 there. What exponent is above the 2 right now? Okay. Now, Riley, when we say gay, we're not being derogatory, we're being gay as in fun, right?
No, it's just the term no.
Yeah, but that's not a very nice term, what I'm getting at, Riley, right?
Okay.
Because there could be individuals in this room who are gay, which is perfectly fine.
No hate to them or anything, but
Yeah. But there's an implication when you say that, though, Riley. I'm just making sure you know.
Let's get back to math.
Let's get back to
yeah, Dominic, let's get back to mathematics.
Okay. What exponent is above the 2 right now that we don't write down? There's a 1 up there, right? So if we follow the rule, this would be 1 times 4. So the answer to this would be 2 to the power of 4 x to the power of 16. Does that make sense to people? Let's go with
Wait,
this.
so you're basically just timesing the 2 to the power 1, so that'd be 4, and then the x by 4. So yeah, that makes sense.
You guys give me the answer for this one. Let's put a 2 up there. What's my answer there? You can leave it in exponent form, Riley. You don't need to do it to. I like it in exponent form. You don't need to follow it out. Oh, okay, I see it. How'd you get 36, Abigail? 6 times 2. Oh, don't square 6. Just times it by 2. I think you went 6 times 6 by accident. So this is going to be 4 to the power of 6 times 2, and y to the power of 3 times 2, which will equal 4 to the power of 12, y to the power of 6. Okay? Let's do 2 more, and then we'll start some harder questions, which are actually pretty easy. Give me that one. Both are correct, Riley. Both you and Stephen are correct.
Wait, so do you times the 2 or do you leave it?
Well, this would be 2 to the power of 1 times 2, 4 to the power of 4 times 2, and y to the power, 3 times 2, which equals 2 to the power 2, x to the power 6, y to the power 6. That's 8. I'm looking ahead.
Yeah, so you don't times the 2 then, right?
No, but you could in this sense. Like if I told you to leave an exponent form, this would be correct. But if I didn't tell you that, this is also like this line. These 2 lines are equal.
Okay, yeah, that's
right?
why that's why I corrected myself with the 4, because I was like, I'm pretty sure it should be 4.
But it depends how I ask it for it, right?
Yeah, that's true.
If I told you I wanted everything in exponent form, there's one answer. But if I told you, like expanded to fill out your numbers, then they're both equal. All right. So now the only thing I can ask now is this. I could do something like this now. Let me circle this one as my good example. Actually, I like this one too. So when you go do your notes of future self, that'd be a great example to write in. Now, I could also start to put these together in the sense of, what if I went like this? Okay. Now the rule when you have this is for lack of a better term, do the top and bottom first. Okay. Then divide. Does that make sense? So figure out your top and bottom first. On top, we're going to do our product rule, so we're going to add these. So that's going to be x to the 10. I'll put the little thing in here in between. Down here, we're doing our product rule, which is, power of a power rule, which is multiplication, which is going to be x to the 6, which is x 2 times 3, and then do your quotient rule, which is minusing. Does that make sense how I did that? But generally, do your top, do your bottom, and then put them together. Okay? So let me give you one here. I'm going to give you guys 30 seconds to do this one. Although I threw in a little bit of a, here, there's a little something a little different in there. I don't think you're right, Riley. Not quite. Oh. Do you see your error now, Riley?
Yeah, it should be 4 instead of it should be 6 instead of the 4.
Yeah.
So Stefan, buddy, you got it there.
So if we work through this one, we're multiplying. So that's going to equal x8, y6. Don't skip this middle step. This one here, there's no x over here, so it's just going to stay x squared. Then we're going to add these two together, which is y3. And then we're doing our division, which is minusing. And we're like such. Okay, give you one more hard one, then we'll go from there. Try that one for me.
Is that a 4?
That's a 4 right there, yeah.
Like the one beside it? Like
Oh,
beside the... Okay.
Yeah, those are both 4s. I tried to make it better and I drew the exact same thing. Oh, this is going to end up as a fraction, won't it? Do you want me to change the numerator there?
Yeah, because don't you have to divide 8 by 5?
Yeah, it would just be a fraction.
Okay. I was going to say, I still want to put it down and be wrong.
I'll put that as a 2. So this one here, the top is going to be 8x14 divided by x to the 5. So that'll equal 4x9. Okay. Let's take a look at your homework real quick. For questions like this one here, just treat them as if they were x's, like where it's -3 here. Same thing as with the x. No, I think you guys are good to go. So when should we come back? Do you guys want an hour to do your homework and eat? So we'll come back at 1 p.m. to finish off the last little part. The last little part's pretty simple. It's 2 exponent laws.
Sure.
Does 1 o'clock sound good or 12:45 better?
1 o'clock.
1 o'clock. Dominic has spoken.
Yep.